Welcome to the General Chemistry 2 class. This section is on physical properties of solution. This lesson is about calculation involving colligative properties. Let's begin. In this lesson, we will calculate boiling point elevation and freezing point depression from the concentration of a solute in a solution. Recall that colligative properties are properties of solution that depends on solute concentration. These properties are vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. For this lesson, we will solve some problems related to boiling point elevation and freezing point depression. Solving problems on vapor pressure lowering and osmotic pressure is beyond the scope of this lesson. In solving problems on boiling point elevation and freezing point depression, we must determine first if the solute is an electrolyte or non-electrolyte. The solid arrow correspond to electrolyte solutes, broken arrows for non-electrolyte solutes. For electrolytes, the Van Hoff factor can be approximated from the number of ions present in 1 unit of solute. The molality must also be calculated from the given amounts of solute and solvent before we can calculate the boiling point elevation or freezing point depression. If asked, the boiling point or the freezing point of the solution can be determined from calculated temperature change and the given boiling point or freezing point of solvent. Recall the steps in calculating the molality of a solution. From the mass of solute, get the number of moles of solute by dividing the mass by the molar mass. You may use the periodic table to find the molar mass values of the elements. The molality can be calculated by dividing the moles of solute by the mass of solvent in kilograms. Example 1. Calculate the increase in boiling point of solution when 0.55 grams of naphthalene is dissolved in 50 grams benzene. Benzene has a boiling point of 80 degrees Celsius and its Kb is 2.64 degrees Celsius kilogram per mole. Paka-cute kayo. The problem asks for the boiling point elevation. To solve this, we need to identify if the solute is an electrolyte or non-electrolyte. Naphthalene does not dissociate in solution, thus it is a non-electrolyte. Use the molar mass of solute to convert its mass to moles. Dividing the mass by the molar mass gives us 0.00429 moles. The underline denotes the last digit that is significant, which is based on the given mass, with two significant figures. Considering more digits is necessary to avoid errors in the final answer, which arise from the intermediate rounding off. The next step is to calculate the molality of the solution. Divide the moles of naphthalene by the mass of the benzene. The unit grams for benzene must be converted to kilograms. The answer is 0.0858 moles per kilogram. Calculate the boiling point elevation by multiplying the Kb of benzene by the molality of the solution. The boiling point elevation equals 0.23 degrees Celsius. Example 2. What is the boiling point of solution when 14.7 grams of potassium chloride is mixed with 100 grams of water? The boiling point of water is 100 degrees Celsius and its Kb is 0.513 degrees Celsius kilogram per mole. Solution. Identify if the solute is an electrolyte or a non-electrolyte. Potassium chloride is an ionic compound and dissociates in water. Thus, it is an electrolyte. Determine the Van Hoff factor. A unit of potassium chloride produces 1 potassium ion and 1 chloride ion. Thus, I is equals to 2. Use the molar mass of solute to convert its mass to moles, dividing 14.7 grams by 74.55 grams per mole gives us 0.1972 moles. Next, calculate the molality of the solution by dividing moles potassium chloride by kilograms water. Make sure to convert the units of mass of water from grams to kilograms. The molality equals 1.972 moles per kilogram. Calculate the boiling point elevation, which is equal to Van Hoff factor times Kb of water times the molality of the solution. The boiling point elevation equals 2.02 degrees Celsius. Add the boiling point of the solvent to the boiling point elevation to calculate the boiling point of the solution. The final answer is 102.02 degrees Celsius. Example 3. In an experiment, 10.87 grams ammonium sulfate is dissolved in 80 grams of water. By how much will be the freezing point of the solution dropped from the freezing point of water, which is 0 degrees Celsius? For water, Kf equals to 1.86 degrees Celsius kilogram per mole. Solution. The problem asks for the freezing point depression. Identify if the solute is an electrolyte or non-electrolyte. Ammonium sulfate is an ionic compound and dissociates in water, thus it is an electrolyte. Determine the Van Hoff factor. A unit of ammonium sulfate produces 2 ammonium ions and 1 sulfate ions, thus I is equals to 3. Use the molar mass of solute to convert its mass to moles, dividing 10.87 grams by 132.154 grams per mole gives us 0.082253 moles. Next, calculate the molality of the solution by dividing moles ammonium sulfate by kilograms water. Make sure to convert the units of mass of water from grams to kilograms. The molality of the solution equals 1.028 moles per kilogram. Calculate the freezing point depression by getting the product of Van Hoff factor, Kf of water, and molality of the solution. The answer is 5.74 degrees Celsius. Example 4. A solution of pesticide named dimethan, a covalent molecule, is prepared by dissolving 0.432 grams of dimethan to 10.0 grams of cyclohexane. What is the freezing point of the solution? For cyclohexane, its freezing point is 6.7 degrees Celsius. Kf equals to 20.8 degrees Celsius kilogram per mole. Identify if the solute is an electrolyte or a non-electrolyte. Dimethan is a covalent molecule and does not undergo dissociation. Thus, dimethan is a non-electrolyte. Calculate the freezing point depression by multiplying the Kf of cyclohexane by the molality of the solution. Plugging in these values, we get freezing point depression to be equal to 4.25 degrees Celsius. Lastly, subtract the freezing point depression from the freezing point of cyclohexane to find the freezing point of the solution. 6.7 degrees Celsius less 4.25 degrees Celsius equals 2.45 degrees Celsius. To summarize, in the calculation of boiling point elevation and freezing point depression, it is important to determine if the solute is electrolyte or non-electrolyte. The Van Hoff factor is incorporated in the calculation if the solute is an electrolyte. To learn more about this lesson, kindly visit the following references. And that's all. Thank you.